Hi, I'm Gabi Lenner, and I am with Azure Data Explorer team. In this video, I will cover cost breakdown of Azure Data Explorer clusters. I will also propose some cost optimizations. First thing we need to understand is the SKUs that Azure Data Explorer supports. And in order to see all the SKUs available in this specific region, we will go to the Scale Up blade in Azure Portal. We see that in this region, we have 7 SKUs that Azure Data Explorer supports. We have 4 D-series SKUs, which are the D11 we are currently using, D12 and D13, D14, and we have 3 L-series SKUs, which are the L4, L8, and L16. The D-series SKU is compute optimized, and the L-series SKUs are storage optimized. The difference between the two is that the storage optimized SKUs are usually used when your scenario includes hosting a lot of data in the hot cache, as compared to the D-series SKUs, which are usually used when you have a scenario that requires a lot of CPU for running heavy queries and running concurrent queries. In order to explain this distinction, I'll compare two different SKUs, one from the L series and one from the D series. So for example, we see that the L16 has 16 CPUs, which is the same number of CPUs that the D14 has. But when comparing their cache, we see that the L16 has 2.7 terabyte of hot cache, as opposed to the 614 gigabyte of hot cache that the D14 has, which is more than 4 times the amount of cache that the D14 has. So when considering which SKU you're planning to use, you should understand first the scenario and how much data you are planning to have on your hot cache. For that purpose, we've built Azure Data Explorer Calculator, which helps you estimate your monthly and yearly cost of your cluster. Moving to the calculator, you see that you need to introduce a few parameters into the calculator in order for it to propose the cost optimized SKU for your scenario, and in order for it to provide you with an estimate of the monthly and yearly cost of the cluster. So first, we need to select the data collected size, which means how many data we're ingesting into the cluster on a daily basis. In this case, I've selected 1 terabyte of data per day. Next is the hot data, which means how many days of data you would like to keep in your hot cache for super fast querying. In this case, I've selected 30 days. Total retention means for how many days of data we would like to keep in Azure Data Explorer cluster, both in the cold and hot data, to be available for querying. The difference between retention and hot data is that the data is still available for querying, but in case the data is not stored in the hot data, the performance would not be as optimal in some cases. Estimated data compression we usually see is around 7, that's the average. In some cases, it can be higher or lower depending on the format of the data ingested into the cluster. Machine SKU is either selected by the calculator when you're selecting choose for me, or you can manually put a specific SKU in order to see the cost associated with that SKU. I'll start with D14, and the last item on the list is the region where you're planning to create your cluster. So for this case, I will use US West 2. So if we're using D14, we see that we need 8 instances of D14 for the amount of data required here, and the monthly cost would be 18K USD, and the yearly cost would be almost 216K USD. If we're allowing the calculator to choose for us, it will select L16 for us, since this is the most cost optimized SKU for this scenario. And you see that we only need 2 instances of L16 in order to keep the entire data associated with these parameters. The monthly cost would be a bit over 5K USD, and the estimated yearly cost would be a bit over 61K USD, which is much better than the other option we saw before. Now that you know how to calculate the overall cost of your cluster, you can go and modify the different parameters in order to see how they affect the price. The most significant factor here is the amount of data stored on the hot cache. For example, if we go and modify the hot data days from 30 days to 15 days, we see that the overall monthly cost goes from a bit over 5K USD to a bit less than 3K USD. Total retention also affects the price, but the effect is less significant. For example, if we go from 90 days of total retention to 60 days, we see that the monthly price changes in less than 100 USD. Additional method for optimizing your cost is by stopping the cluster when you don't need it. And when you do need it back, you can start it again. You do need to take into account that when you start the cluster again, you need to take some time for the cluster to be deployed, first of all, since when we start the cluster, we need to redeploy it. And we need also some time in order to load all of the hot data into the cache, which again takes a bit more time. Another cost optimization is by scaling out the cluster when you need more capacity. For example, if you have an event or a conference that takes place in a specific date and you expect to see more traffic and more queries against your tables and against your data, you can scale out the cluster using either manual scaling or Azure Autoscale in order to have more capacity during the specific conference or event. And once the event is done, you can scale your cluster back again to its original size and pay for the additional capacity and additional scale only for the time duration when you needed it. Thank you very much, and we will be sharing additional cost optimization options later on.